So probability, they start off, and I'm going to be highlighting the important stuff, guys, because remember, we're doing a revision. So they do talk about various terminologies that you need to be aware of. Please make sure you're comfortable with them. Okay, these are basic concepts that are quite useful because they often talk about decks of cards. And if you're not somebody who plays a lot of cards, it might be stuff that you don't actually know. But there's 52 cards in a deck, four different suits. And specific cards, I have a feeling they're actually wanting to say 13 cards in each suit. Sample spaces, guys, that's a list of all your possibilities, things being unbiased, complementary events. We'll look at how to calculate those things. And this is just a general scale. So you got a feeling of what number value gives a good probability. And obviously a definite or certain probability is 1 or 100%. So that is your highest value. Typically, guys, when we're talking about probability, we're talking about the fractions or the decimals. Percentage technically refers to chance, but it is the same value. So we won't differentiate between it in core maths. Okay, theoretical probability is the first thing that I'm going to focus on here. And the theoretical, sorry, I accidentally tapped. Okay, the theoretical probability that I want us to look at is what we're talking about when we're talking about a union or an or an intersection or the word and. Now, I find the majority of people get confused because typically in the English language, if you say or, it's your mom's told you you can buy a chocolate or an ice cream, and it means you're not allowed to have both. And that's what we generally do in English. Okay, but I want you to realize the word or in maths means it could be the A. So in this case, they're talking about A or B. So it could be A, or it could be B, or it could be both. That's what or means in maths. Or is the union, and it could be the A, the B, or the both. So basically, this would be a situation where your mom's being very nice to you, and she's saying you can have a chocolate, or you can have an ice cream, or if you feel like both, you can even have both. So that is what we're talking about when we use the word or in maths, the union. The and or the intersection, that is something that is relatively understandable. It means you're getting the chocolate and the ice cream. So it's A and B. It is specifically both and only both. Okay. So general probability formula is you look at the number of possible things for whatever you're trying to calculate the probability for. So the possible things for the event you're looking for. That's what we refer to when we're talking about something specific happening. We talk about it being an event. And then you're going to look at the total number of things that could happen, and you're going to divide that. That is your standard probability. And do you know what? I think you've been doing that intuitively since you're in primary school. So I'm hoping that that formula you are good with. Okay. Now, what we just looked at is what they call theoretical probability. So here we're going to take the number of things that could happen divided by the total number of things that could happen. But please be aware, if they ask for relative frequency or experimental probability, they're asking for relative frequency or experimental probability, you are looking at the actual things that have happened. Okay, so the key word here in this formula that is different is the things that have actually occurred. So instead of saying, well, I've got a dice and it's got 6 different numbers on it, and it can be, if I want a 3, there's only one way it could happen out of 6. You're actually going to roll the dice a certain number of times. And every single time you do that actual process, it is called a new trial. And that would be the total at the bottom. So it really depends on how many times you rolled the dice. Okay, and that is what we refer to as relative frequency or experimental probability. They do sometimes ask this, so just be aware if they've told you about an experiment actually being done, take note of the difference between the two, okay? So multiplication rule here, if you're talking about and, generally you're going to take the probability of A times the probability of B. You'll find out later that that is specifically for independent events, but we're not necessarily differentiating between that at the moment. So basically, if I were to do something more than once and I want to see the probability of a whole lot of different things happening, the second time I roll the dice, it actually has nothing to do what happened the first time. It is a new roll, it's a new start, so it is independent. And that's when you're going to be using this formula here, okay? This addition rule, okay, you can see they've written it in two different ways. I am just going to highlight the top one. All they've done for the bottom one is they've rearranged it. I want to make sure you understand it, and I'm going to use Venn diagrams, especially since we're doing a revision. You guys should know what your Venn diagrams look like. So there's A and there's B. Okay, so let's see if I can color these in nicely. Okay, so the probability of A is everything in the A circle. Okay. Okay, I hope that's nice and clear. I see I've got a darker blotch in the middle. The probability of B is everything in the B circle. And what I want you to notice is if I add the purple and the yellow, the two circles together, what's happened is I've actually added this section in the middle, where A and B overlapped. I added that twice. I added it with the purple number and I added it with the yellow number. So if I'm looking for the union, guys, and the union is represented by everything inside the circle. So I'm going to, everything in A or B or both. So remember the overlap is the both. And then the A and B's on their own also count. So everything in that red shape that I've highlighted there, that represents A or B. So the problem with me just doing what they've said in this formula to begin with, just if I were to add A and B, do you see that the little I call it, because it looks a bit like a sideways I, that has been added twice. So to just get my red part, I am going to have to subtract one of those overlaps because I've added the overlap in twice. Okay, and this is a very important formula to realize because it's an addition rule that works all the time. And it actually even links to sometimes proving that something is mutually exclusive. Okay, so rather than learning new formulae, if this one makes sense to you, you've got a lot more stuff to work with. Okay. If there's any questions at this point, please ask. Otherwise, I'm moving on to different types of events. Okay. So now we talk about different types of events, and you'll see there's a couple of them that we look at. A and B are mutually exclusive events as they have no elements in common. So the first thing we talk about is mutually exclusive events. Okay. And basically the mutually exclusive events means this here. And the reason why it means that the probability of A or B is equal to just the probability of A plus the probability of B. I want to just show you the formula that I reminded you of just now. Okay, so the formula that I showed you or that we went through just now, I was hoping that to make sure you understand, they added this little bit at the end. Okay, so you'll see that that part is now missing from my exclusive events. Okay, the reason why it's missing is because for them to be mutually exclusive, you'll see here that they've told us that they have no overlap. The A and B part, that little I in the middle, it doesn't exist. There is nothing that belongs to both sets. So when I'm working out with the normal formula that you should know all the time, it looks like you've left out the probability of A and B, but actually the probability of A and B happening is 0 because there is no A and B. Okay, so it's not actually a new formula, but you need to realize that the mutually exclusive means that the probability of A and B is equal to 0. And because that is equal to 0, therefore, it's the same formula we had earlier, except it looks like we haven't bothered to subtract at the end. Okay, but it is actually the same formula. So that's what mutually exclusive is. So they will sometimes ask you to prove this. And please remember, when you're proving something, you look at your left-hand side and you look at your right-hand side separately. So you actually calculate them. If they are equal, then you have managed to prove the statement. Okay, so you would use this formula here with the 0 if you want, it doesn't matter. But you'd use this formula and show that the probability of A or B is equal to the probability of A plus B. Okay, so you'd separate your left-hand side and right-hand side. The other thing that we look at is something that's called exhaustive. Okay, and exhaustive basically means that there's nothing on the outside. So a good example of exhaustive for you guys at school is taking maths or maths lit. Every single child in high school is, or should I say, every single grade 10 child, because we're talking to you as grade 10s. Every grade 10 child is taking either maths or maths lit. There's none of them who are not taking either of those subjects. There's nobody in the outside of those sections. And that means that it is exhaustive. More specifically, my example is actually referring to not mutually exclusive, complementary, which we're going to get to now, because for maths and maths lit, not only are all the children going to be in one of the circles, complementary events are going to be mutually exclusive and exhaustive. Okay, so that's what complementary is. So maths and maths lit would be complementary. I'm just quickly going back to help you with the formula. Sorry, I wanted to remind you of that as well. So basically, because they're exhaustive and you're going to use every single one of those concepts, exhaustive events will always have the probability of A or B is going to be equal to 1, because there's nothing outside of the A or B. Okay, so your for exhaustive, probability of A or B will be equal to 1. And then if we move on to the complementary, complementary is exhaustive and it is mutually exclusive. Okay, so there's 3 concepts, but the one is the first 2 combined. Okay, so let's just go back to complementary then. So complementary, remember, with the mutually exclusive. So the mutually exclusive told us that the probability of A or B would be equal to the probability of A plus the probability of B. Okay, and the exhaustive told us that the probability of A or B is equal to 1. So if we were to combine these 2 concepts to get our complementary, we're basically saying it has to be both of those. It has to be the blue guy and the red guy, which that tells me the probability of A plus the probability of B is going to be equal to 1. Okay, because the A or B is equal to this bit, and the A or B is also equal to 1. So those 2 together makes complementary events. The reason why complementary events are very useful, the most common way we use it is we use the word not, which is basically saying everything but. Okay, but if events are complementary, you don't have to use the word not. So going back to my maths and maths lit thing, the people who do not do maths would be called the complement of it. And we can use that complement because they are mutually exclusive. And do you agree that the people who do not do maths do maths lit? That's exactly the same thing. So you can use the opposite as opposed to actually calculating the maths lit. So what you could do here, so the probability of not maths is equal to 1 minus the probability of maths. Okay, so that 1 minus is the thing that we can use for the complementary. Okay, so Natalia, yes, complementary events have to be exhaustive. So the A plus the B will be equal to 1. It will be equal to your total sample space. There'll be nothing outside of it. And the most common thing of saying complementary is we use that word not, because not is automatically the opposite. But yes, they will also add up. The A or B will also add up to 1. Okay. So complementary needs both things. It needs exhaustive and mutually exclusive. Okay, the mutually exclusive is that blue formula. The exhaustive is the red formula. Putting them together makes them complementary. Okay. Okay, so I hope that's all good. Clearing that up. Okay. So now if you turn over, they've got some diagrams to try and give you a visual feel using Venn diagrams. Okay, Venn diagrams is something that you have to be comfortable with, and they ask questions on it. And it is a very visual way at looking probability, so it helps. Okay, as I spoke about earlier, they've spoken about the intersection and the symbol for intersection, which they do sometimes use. So just please be aware of it. A, it's like an upside down N, the lowercase n without the little tail. Okay, that is the same as the intersection, as the notation that we use. And it's the part where the A and the B overlap. Okay, so for example, if I talk about a 6-sided die, your sample space would be 1, 2, 3, 4, 5, and 6. That's everything that could happen if we're rolling a die. I always forget if I'm supposed to say die or dice, but I wrote down everything that's possible. So I hope you guys know what I'm referring to. Okay, and then we could have 2 different events. We could have odds, okay, which would be the 1, 3, and the 5. Okay, and then we could also have prime. So our prime numbers would be 2, 3, and 5. Okay, so those are my 2 different events. It's like the A and the B, but I've got odd and prime, so I'd probably use an O and a P. Okay, but what would be inside the odd and prime, the intersection of odd and prime? Type it in the chat. What would be the intersection of my odd and prime sets? The intersection, type it into the chat. I want to make sure you guys are all good with that. Thank you, Faith. Thank you, Stephen, Natalia, Lamise, Rapozzo. Okay, let's make sure that we guys know what intersection is now that I've got all of those answers coming through. Okay, the majority I did see were on track. Guys, the intersection is where they overlap, so it has to be in both. So if I have a look here, the 3 and the 5 are in the odd, and the 3 and the 5 are also in the prime. Okay, the 1 and the 2 do not occur in both of them. It's not part of the overlap. Okay, so the majority of you are right, and those of you who got it wrong, please just give me a thumbs up to indicate that you understand that the intersection of these guys would have been 3 and 5. So the intersection, oh, let's change that color. Please just give me a thumbs up to make sure that you're good with it. The intersection of those 2 would just be the 3 and the 5. Okay. That would be the intersection. Okay, great. Awesome. Okay. Then let's look at the A or B. Now remember the A or B, I told you, and I'll give you the notation. A or B, they call it a union, and it's that U, so it's the opposite way around. And it's because you're filling everything in there, okay? So that U is like a bowl, you can put everything you want inside, okay? So A or B, A union B, means I can have anything from A or, so it's A or B or both. Okay, so union means it's either A only, B only, or it is both. So you can see they've shaded absolutely everything there. So please type in what would be part for, if we look at my example, what would be part of the odd or prime set, the union of odd and prime. When I roll my dice, what would be part of the union of odd or prime when I roll my dice? Type it in the chat. What would be the union, the or? So it means it can be odd or prime or both. Awesome. Thank you, Faith. Thank you, Natalia. Thank you, Stephen. Thank you, Emma. Brilliant. You guys are rocking this. Okay, which means maybe I'm going too slowly, but I hope not. Okay. Guys, I'm assuming the other people who aren't chatting is because they know the answer and they're busy trying to, I don't know, do an example or something. Okay. Let's clear all of that. So we've got the idea of the intersection, which is the overlap, the or, which is the one or the other or both of them. Okay, and then they've given you some other diagrams to sort of help you understand the different options here. Guys, if you want, you can learn these off by heart. I definitely wouldn't. Okay, but it does help to make sure you've got an understanding of these things. So we've already just looked at this one. So they've called the sets V and M instead of A and B, because remember, it doesn't have to be the letters A and B. And here they've highlighted everything, the part in V only, the part in M only, and the part where they overlap. So that is the union, no problem. Okay. Then if you have a look at this one over here, the next one, they've highlighted everything that isn't in the union. And you can see there's two ways that you could try and express that. You can either say, well, it's the union, but you put that whole thing in brackets, and that little apostrophe means not. Okay. So basically what they're saying is it's not the union. It's everything except for the union. That little apostrophe means not. So it is the opposite. Okay, and that is exactly the same as not V and not M. Okay, and I'm going to try and shade. The shading doesn't work beautifully here, but I'm going to try and shade to make sure you see that. So if I said not V, so not V, it's going to be everything on the outside of V. So everything outside that circle. Okay. Make sure you're happy with the fact that that's not V. I'm not going to do this for all the diagrams, guys, but it's a good way to check that you understand. So I hope you can see that yellow clearly. I've colored in everything outside of V. Okay. Then I'm going to take my pink and I'm going to highlight not M. So not M is everything outside of the M circle. Okay. That is not M. And I know it's not very easy to see, but there's like a lighter pink and a slightly darker pink. That is where the yellow and the pink overlap. Okay, and remember the word and, or should I say that notation and, means it's got to be where my yellow and my pink overlap. And that is exactly what they had shaded. Okay, so I'm going to sort of clear it all, and then hopefully you can see that that is exactly what they had shaded, everything outside of the circles. Okay, now you can do that with every single one of these circles. You can make sure you understand it by creating it, highlighting, and see where it overlaps, where it doesn't overlap. Remember, overlap is when there's an and everything that's colored in is when there's an or. Okay, so you can play around with these and make sure you're okay. These are the two that it is all based on, the or, the and then I suppose here in the middle, the not is everything that's opposite. Okay, then they've got a whole lot of examples on probability, but otherwise that is probability done. So I'm hoping that this is a section where you guys can get a lot of nice marks. So we're going to basically be practicing, and guys, remember, if there's anything you don't understand, why did ma'am do that? Or hopefully somebody is going to unmute and it's going to be, why did Annalisa do that? You guys are going to hopefully be figuring out what you don't understand by asking. Okay, so we're going to go to the questions and memos, and we're going to get to do a lot of practice on probability. Because we've got so much time on that, I can maybe even just have a bit of a Q&A at the end, but we'll just see how it goes. So let's just go back to our questions and memos, and let's do some probability questions. It's a nice little section that they do grow on. They expect you to remember this for grade 11 and 12. Okay, so they add a little bit every single year, and they expect you to remember. Okay, no questions have come through. Is there anybody who's brave enough to unmute and do question A with us? Oh, okay, guys, that's fine. You're just going to hear my voice. Tree diagrams, sorry, I've just had a question about tree diagrams. Tree diagrams are part of probability. I'm actually going to go back to the course notes and basically just show where you would use it more than anything else. It's more like a method that you can use as opposed to necessarily a direct type of questioning. And I'm going to show you where it really comes to play parts of your understanding. Okay, so yes, here. Okay, so here we spoke about an addition rule and a multiplication rule. The multiplication rule especially is pretty much used for tree diagrams. So you can only really do your tree diagrams when your choices are not dependent of each other. So it's when you've got independent events, independent. Okay, then you can use a tree diagram to help you calculate. So I can give you an example of that, and I'm actually going to go back to the questions and memos basically, and I'll come up with an example where we use a tree diagram just to make you familiar or remind you what it's like, but it's actually more for helping you to work things out than something that is tested directly. I know they tested directly in grade 9, which means they could ask you again in grade 10. So I will revise it with you. So yes, I will actually revise it with you in question B. So I'll actually use the questions that I've got there, and I'll show you how we can work it out with question B. Okay, so we're looking at question A first. And thank you for that question, Makhadi. That was a brilliant question. Okay, so the probability of A, they said, was equal to 0,3. I'm just writing down the information that they gave us over here. The probability of B is equal to 0,65. And the probability of A or B is equal to 0,74. So they haven't given you a story. So if this is very theoretical, making sure you understand stuff, which is kind of a hint that you're going to use your formulae. Okay, so that's what they've given you, and they've said calculate the probability of A and B. Okay, so number 1, they want the probability of A and B. Okay, so that's what they're looking for. Guys, they're not asking you to try and figure it out based on any kind of a story. It's based on a calculation. And there is only one formula that, as I said, I want you to remember this formula all the time, because even the other stuff is dependent on knowing this formula. Okay, so the probability of A or B, remember, is equal to the probability of A plus the probability of B, but then we had to subtract the intersection, because remember, we added it twice. And Natalia, I've seen your answer come through already. Thank you very much. I'm going to make a note on notation, guys. You'll see here the P's tells me I'm working out the probability of A or B. So the probability of A or B, they said, was 0.74. So you substitute everything you know. Guys, there might be a little bit of algebra involved, but you guys do algebra and everything. Probability of A is 0.3. Probability of B is 0.65, but I don't know what this one is. Okay, so now you have to solve the equation. You need to get the probability of A and B on its own. And guys, I don't want negative the probability of A and B. So I'd probably move that over to the left-hand side and get it on its own there, which means obviously that this guy is going to have to move to the right-hand side. So I'd like you all to solve that equation and make sure you're good with it and work out the probability of A and B and put it in the chat. Okay, I've already got two different answers. Okay, I'd like you to work that out for yourselves and type it in the chat. Okay, we've definitely got a majority rules here. I love the question mark at the end of it, because it means you're not 100% certain you got it right. Okay, so we're going to go through all the steps to make sure that we know why we got it right or wrong. Okay, so as I said, the probability of A and B, it was a subtraction, so I moved it to the left and then it became positive. On the right-hand side, I've still got 0.3 plus 0.65, but then I have to move the 0.74 over. So I go minus 0.74. There's another question mark. Okay, so you're going to work that out and you're going to get 0.21. You can type it into your calculator. Yes, well done, guys. For those of you who got it right, it was the majority. Just please double check if you didn't get 0.21. Make sure you understand what we've done here. Otherwise, ask. Okay, I've been asked why we're using this formula. So the only other formula I think you could be referring to is that the probability of A or B is equal to the probability. So I'm going to look at the different formulas that you've got as options. Okay, so you've got that one there. And then you've also got that the probability of A and B is equal to the probability of A times the probability of B. Okay, so you've got a green one and a pink one there. We're going to explain why both of those aren't okay. To make sure you guys understand where you would use these formulae. Okay, this green one is only valid when they are mutually exclusive. Now remember, we don't know what these events are. They haven't told us a story. We don't know what's happening in A. We don't know what's happening in B. It could be the same sort of situation as my prime and odd, which did have an intersection, which means it's not mutually exclusive. Okay, they've just told me that this is what the probability of A is. So we've got no facts to be able to assume, oh, wait, I can use the mutually exclusive rule. So I have to use the basic rule that works for everything. This orange one is valid every single time it is valid. So unless you've been given a special information, you cannot use the special formulae, but this orange one can be used all the time. The pink guy, okay, is only valid for independent events. Okay, so the example that I gave you when I roll a dice with a prime number or an odd number, okay, every single time I roll, it is a new roll. It's got nothing to do with what happened in the previous roll, okay? That is what it means for the events to be independent. And it is what we'll end up using when we're doing tree diagrams. You can get tree diagrams that are dependent, but they get really messy and they're not necessarily an easier way of looking at it. But those are the only times that you can use the green or the pink formula. Okay, and if we have a look at our question, they said the two events are A and B. And the only thing they gave us was certain probabilities. They didn't tell us that they were mutually exclusive. They didn't tell us they were independent. They told us nothing else about the events. So we cannot use those special formulae. I hope that answers the question. Please let me know if that makes sense. Okay, great. Okay, so that orange formula, that works for everything, guys. So unless you see the words mutually exclusive or independent, or you know for definite that they're going to be independent, you can't use the green or the pink formula. Okay. The next thing they asked us was, hence represent the above information in a diagram, a Venn diagram, sorry, not just any diagram. Okay, so now we're going to represent this in a Venn diagram. So let me just quickly make some space here. Move that stuff down. Okay. So our Venn diagram, remember you've always got a block because the block is for the entire sample space. Then for every event, you're going to have a circle inside there. So A and B. Okay. And we've just worked out that the overlap part is 0,21. So we're going to have to use this thing here, the 0,21. Okay. That will be the overlap because that's the AND bit. Okay. They've told me that the probability of A is 0,3. But please realize that is for all of A. Okay, so that entire circle has to be 0,3. And then lastly, well, not lastly, but this entire circle for B, the entire circle has to be 0,65. And the reason why I'm stressing that is I cannot put two values in B and they don't add up to 0,65. So you always start with the overlap of a Venn diagram. You try and start with everything that's combined first. So that's 0,21. And I'm hoping by now, because I did some explanation, that you guys have an idea of how you would do it, or you have already done it so that you can check. Okay, so that intersection is the 0,21 that is in the middle there. Okay, but the entire green circle, the whole circle for B has to add up to 0,65. So I'm going to write down the calculation we're doing. We're going to go 0,65, but we've already represented 0,21. That's already in that circle. So I'm subtracting that. Okay, and that's what's going to give me the green bit, which is going to be 0,44. Please check my arithmetic. Yes, great. Okay. Guys, and now that I've done B for you, I would like you to do, so I've shown you how we're going to do, this was just the calculation. That was just the calculation. I would like you to tell me what part is going to be filled in here by the A part of the circle. What are we going to fill in there? Type it in the chat. I want to make sure you guys are good with it. Type in the chat. What's going to go in this side here for A? Okay, guys, be careful of your decimal places. It might just be because you're typing really quickly. I did see somebody correct themselves. Okay. Now I'm going to make sure you guys know why. So this entire circle has to be 0,3. So we're going to take the 0,3, but I've already written down 0,21. So I'm going to subtract the 0,21. And if I work that out, I should get 0,09. Okay, make sure you're okay with where that 0,09 came from. And again, I've just done the calculation there in pink to make sure you know where I got the 0,09 from. Okay. The last thing we can do is actually do a quick check. Well, it's not quite the last thing because my Venn diagram's not finished. I'm going to just do a quick check here. And remember that they told me that A or B is everything inside the circles, has to be 0,74. So I'm going to add up everything I've got in the circle. So that's 0,09. We're going to add the 0,21 and we're going to add the 0,44. I would like you guys to all add that up and tell me, does your check work? Does it give you the right answer? Yes, Emma, great. Okay, and that's a way that you could check. Yes, brilliant, Natalia. Okay, so I know that when I've added up all my circles, it had to give me the 0,74, and that's a nice way that you can check that you didn't make any silly mistakes. But can you tell me, what is the total probability that anything could be? What is the definite probability once I consider everything in my sample space? Thank you, Hlingiwe. Thank you, Makadi. It is 1. Guys, so if everything has to add up to 1, at the moment, everything in my diagram only adds up to 0,74. So I need to put something else in my diagram. You're going to tell me how much I need to put in the diagram and where I'm going to put it. I know that's a difficult one to type in the chat, but you can unmute. I always love hearing your voices. Okay, Mukhadi's got it. Yes, Klingiwe's got it. And the rest of you, I need to hear that you don't know or get the answer. Okay, great, right answer, but not too sure where. Stephen, brilliant. Yes, Natalia. Okay, guys, so my last calculation. Everything all together has to be 1. I've filled in my circles. I'm not allowed to put anything else in the circles. But remember, I drew a whole big block. So outside the circles is everything that's not in B. So I'm going to take 1 because 1 represents the entire thing. I'm going to subtract the 0,74, or you could say I'm subtracting everything else that I've got. And that gives me an answer of 0,26, which is going to be outside the circle. Guys, remember all these pink bits, I'm writing down the calculations so that you know where I got it from. I would not expect those calculations in your Venn diagram. Okay. I would not expect it in the Venn diagram. So guys, yes, in the end, everything in the block has to add up to 1. If we're talking about probabilities. Now that's where the trick comes in, because sometimes our Venn diagram doesn't have probabilities in it. It has the number of elements. Okay, so, or they just list things, and I'm actually going to show you different examples of that now quickly. Okay, so I'm going to go back to my prime numbers and my odd numbers if it's okay. And we're going to make sure we understand the different ways that we could represent the same thing in a Venn diagram, because this Venn diagram, I can see some of you are a little bit uncertain still, that the entire block would add up to 1 if we're dealing with probabilities. So I'm going to just quickly remind us of rolling our dice or die, I don't know. The sample space is 1, 2, 3, 4, 5, and 6. Just a normal 6-sided when you're playing board games, okay? So it's got 6 sides. That's everything that could happen. Then we had our prime numbers, which was 2, 3, and 5. And then we had our odd numbers, which was 1, 3, and 5. Okay. And now we're going to represent that in a Venn diagram in 3 different ways. Okay, so the first way is by listing the actual elements. Now this can work in something that's small like this, okay, but it wouldn't actually work in every single situation. So my whole sample space, I've got my prime numbers, I've got my odd numbers, and we're going to go through the list. 1 is an odd number, but it's not prime, so it's going to go in the O only part. 2 is a prime number only, so that goes into the prime only part. 3 is prime and odd. 4 is not prime, it's not odd. It can't go in the circles, and that's why we've got a block. Okay, 5 is going to be prime and odd, and then 6 is not prime and it's not odd, so it goes on the outside. That's what our Venn diagram would look like if we represented it using the elements, the actual things that are going to happen, which we could do because we just had 6 possibilities. Now you could imagine if I teach at a school with 1,000 children and I'm placing 1,000 children in whether they do geography or history, because those are the only 2 choices for whatever reason. Okay, and if I tried to list every single one of their names in a Venn diagram, it would take forever. Okay, so we wouldn't actually use the elements themselves. The other thing you can do is the number of elements. Okay, so the same situation, got my sample space, got my prime numbers, got my odd numbers. Now we're just going to say how many things are in each section. So do you see that there was only 1 thing in the prime only? There were 2 things in the overlap, the intersection. There was 1 thing in the odd only, and there were 2 things outside the circle. Please make sure now this is confusing because the elements were numbers, and now number of elements is also numbers, but you see that the numbers represent different things. It's telling me how many things were there. Whereas in the first example, I was actually listing which values we were going to have. And the last one is the probability, which is what we just did. The question that we just did, we did it with probability. Probability. Okay. So there's a sample space again. My prime numbers, my odd numbers. And now we're going to put the probabilities. So remember, the probabilities is how many things could happen over the total number. We've got a total of 6 things that could happen. So in the prime only part, it's going to be 1/6. In the odd only part, it's going to be 1/6. And tell me if this freaks you out, but in the intersection and outside the circles is going to be 1/3. Think about that for a moment. And if 1/3 does not sit well, I shall explain why I wrote 1/3. But those are the differences. And if you take the probability one and added all those numbers, the probability, yes, will always add up to 1. Okay. So it does depend on which method of diagram you guys are doing. Okay, so I've had nobody saying where did a third come from, so I'm assuming you guys all know that it was 2/6 and then I simplified it. Okay, I'm assuming you guys know that these were 2/6 and then we simplified. But those are the 3 different things, so it's exactly the same. My prime and my odd numbers, Venn diagrams written in 3 different ways. Okay. Does probably always become a fraction. Probability can be a fraction or a decimal. It doesn't really matter. The reason I didn't write them as decimals is these would be recurring decimals, and the fraction is accurate. So With the fraction being accurate, I don't have to worry about rounding off. So that's the reason why I chose to do fractions, but decimals are fine as well. That answers that question about decimals or fractions. Okay, then I've been asked, ma'am, can you explain that? So I don't know if you're asking me to explain the 1/3 and it came through late. Okay, there we go, great. Okay, so the 1/3 was a 2/6 for both of them and we simplified. Okay, everybody happy with that? I feel like I need to actually wait a little bit longer because some of the things are coming through in the chat a little bit slower. But it's the same scenario in 3 different ways in the Venn diagrams. So please just pay attention to what information they're portraying in the Venn diagram. If it's probabilities, if it's the number of elements, so number of elements, I said probability would always be equal to 1. The number of elements would always be equal to the total number of elements. Okay, total number of elements. So if you added them up here, because we had 6 possibilities in total, that would add up to 6. Okay. And then when we're talking about the elements here, you're actually just listing specific detail. So you would have to count how many elements there are. It's always a good idea to simplify, but we do not take marks off if you do not simplify. So I've got a question, do we simplify the final answer or leave it as is? It is actually either way, it's fine, because here we are not testing whether you can simplify fractions. That happened in primary school. We're actually testing probability. You might ask your teacher, because I know you guys are getting marked by your teachers, they definitely will not penalize your matric. But at your teacher, if they want to get you to get used to simplifying, they might be sticky with it. So rather ask your teacher, but you don't have to simplify because it's the same value. Okay. Okay, great. Let's carry on with that question. So we did our Venn diagram. We found out that it was going to add up to 1. Let's do this one more question and then we can take a short break. So one more question. Are the events A and B mutually exclusive? Give a reason. So guys, you need to remember, what does it mean to be mutually exclusive? Okay. So mutually exclusive, and I'm going to just summarize up there. I've called it ME instead of writing the whole word out. Remember, that happens when there is no overlap. Okay, so your probability of A and B would be equal to 0 because there's no overlap, which basically gives the same formula that I said we could use all the time. But if you work out your probability of A or B, and you work out your probability of A plus your probability of B, they will be equal to each other. And that shows you that they're mutually exclusive. So those are the 2 pieces of information that you get from mutually exclusive. You do not need to use both of them. Either of them, they both say the same thing. So you guys tell me, in this situation, the events A and B, were they mutually exclusive? I see I've already got a couple of answers. So the no, and I'm so glad you guys gave reasons. This was a 2-mark question, and a lot of the time they don't give the mark for no unless it comes with a reason. So rather guess than leave it blank, but always give a reason as well. Okay, because they have an intersection. The intersection is not 0 because they overlap. Okay, so be careful saying they overlap, rather give the calculations that you've got. So in this situation, guys, okay, but all of you are pretty much saying no. Okay, great. So just making sure you know how we would write that down. Okay, so for question 3, you would say no, and your reason is because the probability of A and B is not equal to 0. Or you could have said the probability of A and B is equal to 0.21. 0.21. Okay. So those are the 2 ways you could have explained it, or that I would have explained it. And if you give both of those pieces of information, then you're covering all your bases. Okay, so the probability of the A and B was 0.21. the not equal to 0 because it had a value inside there. Okay. Next question. Okay, so it says here, a circular spinner is divided into 12 equal sectors. Each sector is numbered from 1 to 12 when spun. The spinner has an equal chance of stopping at any of the numbers 1 to 12. So before we get to the question, Monique, you said you'd be happy to help us. Can you tell me, what do you understand from the words equal chance?
It means that none of the sectors are weighted. So if it lands, the probability of it landing on 1 is the same as the probability of it landing on 2, 3, 4, all the way to 12.
Awesome, great, thank you. And yes, Emma, I see you said 50-50. Absolutely, kind of like 50-50, but 50-50 is when we're only flipping a coin, or when we've only got 2 chances or 2 different things that could happen, because then we've split it as a 50-50, and that's why we call it that. But in this situation, we've got 12 equal sectors. But yes, equal chance, they all got exactly the same chance of it happening, but we're splitting it into 12 instead of 2. Okay, so no, awesome. You understood exactly what it meant, and I love that. But also, are you willing to help out with our next question, Emma? Maybe. I love that idea. Okay. Okay, so let's have a look, Monique. So yes, absolutely, it's going to be equal chances. So the very first question that they've asked us for over here is they've said, for any random spin, what is the probability that the spinner will stop at a square number?
So from 1 to 12, our square numbers are 1 squared, so 1, 2 squared, 4, and then 3 squared. So that is our set.
Okay, so those are all our possible perfect square numbers, yes.
And we have established that each section has an equal probability. Someone's beating me to it, equal probability of it landing on there. So our total probability of 1 is divided by 12. And because 3 events are of interest to us, it is 3 over 12.
Awesome, thank you. And I did see that Faith and Klingiwe also came in and said what their answer was. Guys, remember, it doesn't matter if I've got somebody else answering in the chat, whether it's me or somebody else answering, you guys are all doing the question. So I need you all to be still trying and sending through your answers, because the only time you realize if you understand or not is when you actually try it yourself. Okay, so yes, it's 3 over 12, perfect, Monique, and that, as some of you have said, you can simplify that to 1 over 4, but guys, it is not necessary. Okay, the next question says, the number that the spinner stopped at after the first spin was recorded. The number that the spinner stopped at after the second spin was also recorded. Calculate the probability that the sum of the 2 numbers at which the spinner stopped is greater than 2. Okay, so let's all think about the probability of the sum being greater than 2. Greater than 2. Okay, Monique, do you have any ideas on that one?
Can I use a complement?
Okay, so guys, just to remind all of you, the complement, remember, is when we go 1 minus. So we're going to calculate the opposite because it actually might be easier. Okay, so instead of doing that, so we'd actually be working out 1 minus the probability that the sum is equal to 2, because that's going to be a lot easier to work out. What are those probability that the sum is going to be equal to 2? Okay, and how would we get the probability of the sum equal to 2?
We would consider which of the numbers of the 12, which 2 of them, which likely combinations of 2 of them would sum to 2. And in this case, it's only 1 and 1. So,
okay, so I'm just going to make sure everybody understands what we're doing. So we've got 1, 2, 3, 4, 5, 6, 7. These are all our possible numbers when we do our spin, guys. I'm just writing them all down. Now, if I spin twice and I needed to add up to 2, Monique's basically said that the only way that's going to add up to 2 is if we spin a 1 and then we spin a 1 again. Okay, yes, Monique?
So, and because if you were to draw a little table for yourself so that you can consider all of the options, you would have for the first a row for the first spin, and then along the column you would have the possible options for the second spin, and you will have 144 possible outcomes for the
so your first spin there and your second spin, you said you wanted to do a row and a column.
yes.
Thank you for somebody who pointed out the fact that I wrote 10 twice and left out 11 in my data set. Okay, so we've got 1, 2, 3, and then our second spin is going to be 1, 2, 3, 4. Okay, so basically if you have a look underneath that and across from that, that's if I get a 1 and a 1, that's if I get a 2 and a 1, a 3 and a 1, etc. That's what my table's looking like, guys, but I'm not going to do the entire table, but that's the table that Monique is referring to. Okay, and yes, because there's 12 going down and 12 going across, that means 12 times 12 is 144.
And it's 12 times 12 because for each of the 12 outcomes for the first spin, there's 12 outcomes from the second spin. That's why it's 12 times 12.
Yeah. So it's kind of like we're going 12 down and 12 across.
And we already said, so going to our probability now, we said that only one of those sums is what we want. So it's going to be 1 minus 1 over 144, which gives us 143 over 144.
Okay, sorry guys, I did see the stuff coming through in the chat. I was just waiting for us to finish the question. So first of all, thank you, Monique, absolutely brilliant.
It's a pleasure.
Okay, so we were on question 5.1b, number 2. Okay, somebody asked which question we were on. So we're on 5.1b, number 2. And I've been asked a few things. So let's just quickly go back. First of all, why did we decide to go 1 minus the probability of the sum? Okay, and I'm going to show you a tree diagram. So you can use this table that we drew down at the bottom here, where you get 1, 1, 2, 1, 3, 1, 4, 1. It's kind of showing your first spin and your second spin, or 1, 2, 1, 3. Okay, and I'm hoping you're okay with the fact, without me drawing the whole table, guys, but you would land up with 144 squares because you're going 12 across and 12 down, which gives you all the different combinations. Okay, so doing that kind of tells you that here, this is the one that we're looking for, the 1 plus the 1, which would tell you that I'm going 1 minus 1 over 144. If you do this table though, another way you could have looked at it is said, well, doing this table, I see that out of my 144 options, everything else, okay, was also going to be an option. Okay, so we've created this table showing everything that could be in my first spin and second spin. It's all the different combinations. Okay, so I'm hoping you're okay with that. If you're not, please tell me. And you're going to get 144 of them. So if the only one that's going to give you a sum of 2 is this very first one, everything else will be bigger than 2 if I add them up. Because remember, they asked about a sum greater than. So then from that, you should be able to see, okay, straight away, and you might have jumped to that straight away and not done the 1 minus. It is perfectly okay. So guys, depending on how you've worked it out, this is a problem solving question. It's not a straightforward probability. Some of you might have jumped straight to that answer, and that is perfectly okay. I definitely would have done the 1 minus because I didn't think of the table. So Monique thought of the table, which is great. I was thinking of a tree diagram. And if I were to draw a tree diagram, it would be very painful because I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is one of the reasons why I want to show you the tree diagram, is because you guys asked about it. So every single thing that could happen the first time I spin, I could get a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, an 11, or a 12. And then for each one of those, I have to draw, and I'm not going to do it, I have to draw 12 more branches for every single one of those numbers, because that's in my second spin. I could also get a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. Then I would have had to add them all up, and I would have got the 1 plus 1 would have given me 2, the 1 plus 2 would have given me 3. So I would have added up all the sums. But as we've just discovered, there's going to be 144 of them. So instead, I paused and I thought, wait a second. If it has to be greater than 2, that is the opposite of being equal to 2, which means I just have to look at one scenario, one situation, which is why the 1 minus can make it easier, because by doing the 1 minus, and as I said, not compulsory, but by doing this, sum being equal to 2 is only going to happen once. Okay, and the probability of the sum being equal to 2, the first time it had to be a 1, so it would have been a 1 over 12, times by the second one would have been a 1 over 12. Remember, when we're talking about independent things, when we spin, each spin will be independent. So we were allowed to multiply. So that's another way you could have got the 1 over 144. So guys, there's actually quite a few different ways to think of this, and they're not wrong. So this is actually the perfect opportunity. If you thought about it in a different way and you want to make sure that you got your answer correctly, as in you were thinking the correct line of maths, please, this is the perfect time to ask. Okay, thank you for correcting my data set. Okay, Natalia, like I know you didn't know which question we were on, so I'm hoping it's okay now.
Ma'am?
Everything except the 1 and 1. Yes, Hussein, ma'am. Natalia.
Yes, ma'am. Ma'am, I just wanted to ask, where did you get the 1 to say 1 minus P?
Okay, so remember when we did the complements, remember the opposite, the not.
Yes, ma'am.
So if I was working out the probability of choosing somebody who does maths lit, I could go 1 minus the probability that they do maths.
Okay. So it's more of like a comparison, ma'am.
No, so it's because I decided to look at the opposite thing. So they asked for the probability of the sum greater than 2. So I looked at the opposite of being greater than 2, which was equal to 2. Well, it's actually equal or less than 2, but it couldn't be less than 2. Okay. And if I want to look at the opposite, I will go 1 minus, because remember, all the probabilities have to add up to 1. That's where that 1 comes from.
Okay, ma'am, I understand.
Okay, great. Be everything except the 1 and 1, since 2 is not greater than 2. Yes, great. Klingiwe, please further explain. I do not understand. Okay, so Klingiwe, I'm not too sure when that came into the chat.
Ma'am, it came in a while ago and you explained again, so it's okay. You can continue.
Yay, great. Thank you, Klingiwe. Okay, so we're all happy with this. It is a bit of a level 4 question. You might have tried different things, the table, the tree diagram. You might have done 1 minus and you might not have. But did we all happy with 143 over 144? Okay, great. And thank you, Monique, so much for joining us with that. Okay, Emma, you said I might be able to pick on you for the next one.
Hi, ma'am.
Hi, Emma. How are you doing?
I'm good, and you?
I'm good, thanks. It is so nice hearing somebody else's voice. I cannot even begin to tell you. So I really appreciate that you're letting me pick on you, Emma.
Yeah, it's a pleasure, ma'am.
And you know what? See it this way, because this is the best way to try and make sure that you understand this stuff. So it's actually for your benefit as well. So I'm not picking on you, I'm helping you out. It sounds friendlier. Okay, so I don't know how your Venn diagrams are. So this is the next one. It says in a certain class of 42 boys. So here they're giving you information on the total in the class, okay? So if you're doing probability, that would be in the denominator. They say 27 play hockey, 32 play soccer, 7 do not play hockey or soccer, and an unknown number play both hockey and soccer. They've given you a Venn diagram and they want you to calculate this value X, which was the unknown number. Emma, any ideas of what you're going to do there?
Ma'am, could we make an equation?
Brilliant. What equation do you want to make? Because it depends what equation you want to make.
I think 27 minus X. I'm not sure if it's you plus the 32 minus X.
Okay, well, tell me what you're trying to do.
Make them all equal 42.
Okay, so they've told us the total. Guys, and remember earlier I showed you the Venn diagram, the 3 different ways. Probability has to add up to 1. Then if they're telling you how many things are in each section, so here they didn't list the boys' names, they're just telling me how many boys are in each section. It has to all add up to my total number of boys. And Emma, you're right, it has to add up to that. So I would have had to add the 32 minus X. Okay, so we've got 27 minus X plus 32 minus X. Emma, can you carry on?
Plus 7 is
Mhm.
equal to 42.
Okay, what about this one in the middle?
Oh, minus X.
Or minus?
Oh, I mean plus. Sorry.
Plus, we add them all up. No, that's fine. That's perfect. Is equal to 42. Okay, so I see that came through from Klingiwe and Stephen as well. Just make sure, guys, you add every single section. So I don't know if it's because we were tired of typing or trying to type very quickly. Okay, so Emma, I don't know if you need your calculator or if you want your calculator with you, if you've got your calculator with you.
I got it.
Okay. Great. We are now going to try and solve for X. So let's neaten this up and add our like terms first. And what are we going to get?
66
66
minus X.
minus X equals 42.
Yes.
Okay, so that was the 27 plus 32 plus 7. That gives me the 66. And if you go minus X plus X, that gives me the minus X. Okay, and then we're going to finish that off.
We're going to subtract 66 from 42.
Okay, so we get negative X is equal to?
Negative 24.
Yes.
I think. And then we divide by negative 1.
Okay. And X is equal to 24. Brilliant. I saw a couple of you guys doing it with us and going through. Emma, you're not done. Hey, you're doing this whole question A. I just wanted to. Okay, I'm just double checking this. It's just another way of putting it. Oh, okay. Yes, that's fine. You're just simplifying straight away. Got that, Stephen. Okay, great. You have to minus 7, not 6. Sorry. Okay, so we're all good. We got the right answer there. So we now know our X is 24. Guys, I'm actually going to just quickly, on our diagram, fill in what we know. So we know that this is actually now 24. And 27 minus 24 is 3, I think. Please check my arithmetic too there, guys. Then 32 minus 24 is 8, I think.
Yeah.
Great. And you can also double check and check if all of those numbers are going to add up to 42. Okay, so we've got the hockey is 3, then the overlap is 24, the soccer is 8, and outside is 7. Okay, so then they're going to start asking you questions on all of this. So what is the first question on this? Okay, it says, if a boy from the class is chosen at random, calculate that the probability that he does not play hockey or soccer. Okay, so I've gone back up here to the top we want the probability not hockey or soccer. Guys, please notice I do the P when I'm trying to say I'm taking the probability of, but you'll notice my answer will just be a number. Okay, so not hockey or soccer. What would we do there, Emma?
Would we say 7/42 because they play nothing?
Okay, because 7 of them do not play hockey and they don't play soccer. Okay, we don't be so mean though, Emma. They might play rugby or something, cricket. Don't play anything. You don't know. Okay, and so that is 7 over, and then our total, remember, was 42. Okay, and you can simplify that. I think 7/42 is going to be, I think, 1/6.
Yes.
Okay, so that was the next one, is not hockey or soccer. Then after that, plays only soccer. So the probability that it's soccer only.
Would that be 8/42?
Okay, guys, the word only is very important. Yes, Emma, sorry. She's like, will that be? And I don't answer you. Yes, it will be 8/42. Thanks, Emma. And guys, please remember the word only is very, very important. So you'll notice here, they said 27 play hockey. They have left out the word only. So that means that this entire hockey circle has to add up to 27. Okay, it doesn't mean there's going to be 27 and then something else. You'll see that the 3 plus the 24 add up. So the fact they've left out the word only automatically means the whole thing. If they put in the word only, like they did here, only soccer is just those 8 children there. So that would have been 8/42. Okay, which, yes, you can simplify to what, 4/21. Okay, thank you, Emma. And I think, was that the last one that they asked? Yeah, so then it's on question B. Thank you very much, Emma.
Pleasure.
Hlengiwe. See, now some of you spoke to me earlier, so now I know that you guys have mics. Hlengiwe, please help me with question B. Oh, come on, you can't leave me hanging. You got such a beautiful voice. Please, we'll do it together.
Ma'am, I'll have to respectfully decline. I'm very shy and
Oh.
I'm very slow-witted, so I'll have to decline. I'm sorry.
Oh, you're breaking my heart, Hlengiwe. Brandy, do you have your mic with you?
Ma'am, can you hear me?
Yes. Can you help me with question B, Brandy?
Question B. Okay.
Okay, we're doing it together. So, like, don't worry, I'm going to read it. And you can see I've already started adding something, because if I moderated this question, I would have said that it's not clear. So I'm already adding something over here. It says a bag contains 3 blue balls and X yellow balls. And it says write down the total number of balls in the bag. And I'm writing here in terms of X. Okay, so that means that you're not going to get an actual number, you're going to get an expression.
So, ma'am, is it X plus 3?
Absolutely. How easy was that, Brandy? Yeah. You're a rock star. So now I can pick on you again later. No, I'm kidding. I won't. Don't worry. Okay. Number 2, if a ball is drawn from the bag, write down the probability that it's going to be blue. And here again, it should have said in terms of X. So again, you're not going to get an actual number. You're going to get some kind of an expression that has X's in it, Brandy. So how many, yes, Faith, I do see you coming through, and well done. So how many blue balls were there?
There was 3, ma'am.
There were 3, okay. And what was my total again?
Yeah.
How many balls were there in total?
Wasn't it like X plus 3?
Yes, it was X plus 3. Ta-da!
Okay, ma'am.
Thank you. Thank you, Brandy. I really appreciate it. I hope, was that okay?
Yes, ma'am.
Okay, great. Thank you very much for joining me. Okay. I'm going to take a shot in the dark. Chloe, do you have your mic with you? Chloe, do you have a mic? Chloe is not responding. Ah, okay. Dimple. I know Dimple's been active on the chat earlier this week, so I'm hoping. Okay. Okay, I'll stop now guessing and I'll start picking on somebody again just now. Okay, guys, let's have a look at question 5.2. Question C. Complete the following statement. If A and B are two mutually exclusive events, then. Okay, and Klingiwe is already typing in the chat. And Klingiwe, I do appreciate the fact that you're always on the chat as well. So I do appreciate that. Okay, so it says complete the following statement. So we started off with probability of A and B, but guys, try and think, remember this is the learning part, what it means for it to be mutually exclusive. Thank you, Emma. I've seen yours come through. Thank you, Stephen. Okay, what it means for them to be mutually exclusive, remember, the very unmathematical way of saying it is that there was no overlap. And the overlap represents the and part. Thank you, Brandy. Okay. So over here, if we're trying to find out what needs to carry on after this, if they're mutually exclusive, the probability of A and B is equal to 0. Okay, you just had to complete the statement, so you would have got 1 mark just for realizing that A and B is 0. Okay, and that was kind of a hint because you had to remember that to be able to answer the next question. It says, given that A and B are mutually exclusive, so now they're telling you that it's mutually exclusive. Okay, so if they've told you it's mutually exclusive, guys, I want you to remember that that means I can use a specific formula. The mutually exclusive formula is the fact that probability of A or B is equal to, this is the stuff that we remember, probability of A plus the probability of B. That's what happens when it's mutually exclusive because the intersection is 0. So then you're just subtracting 0. It says the probability that event A occurs is 0,55. So the probability of A is 0,55. And the probability that event B does not occur. So that's the probability of not B. Remember, that's with the little apostrophe. Sometimes they do use the notation. Okay, so that looks like this when you write it using the fancy notation. Okay, is 0,7. So now let's just quickly think about it before we start calculating. And if you guys are ready to calculate, great. They said calculate the probability of A or B. So this is what I need to calculate. So that is my question mark. That's fine. I've got the probability of A that I can substitute in my formula. I do not have the probability of B though. Do you see I've got the probability of not B? For my formula, I need the probability of B. So before I can start using that formula, I need to calculate the probability of B first. Okay, so I want you to either type in the answer for the probability of B or an explanation of how you would get the probability of B. That is going to be my first thing because all I've got at the moment is the probability of not B. Okay. Okay, so I've got an answer from Natalia. And from Brandy with an explanation, brilliant. Okay, I've got an answer from Klingiwe. Okay, guys, I want to remind you that not is the opposite. Okay, it is the complete opposite of what you've got. So if I'm looking for the complete opposite, I'm looking at the entire thing and just taking out what I've got there. So the opposite would be the entire thing, which is 1, subtracting what I need to get the opposite of. Okay, so I'm so glad that I got it. I don't know as well. So the word not immediately tells you you're going to go 1 minus the probability. Okay, 1 minus the probability. That's what not means. It is the opposite. So your total, which is 1, because we're talking about probabilities. Okay, so your total minus. So to get the probability of B, I'm going to go 1 minus the probability of not B, which is the B with the apostrophe. Okay, and if I work that out, it's 1 minus 0,7, which gives me 0,3. Now that I've got the probability of B, I can use that green formula that is for mutually exclusive. Okay. Oh, the answer for question number 1, sorry, I see Makhadi, you lost it. It's literally written there in the sentence. It's just a 0. Okay. Okay, guys, I hope you all followed how we got the probability of B, because I got some correct answers, some incorrect answers, and some I don't knows. So this is now your opportunity to let me know if you are still confused. But for my mutually exclusive formula, I needed probability of A, I needed probability of B. I had the probability of A. To get the probability of B, I had to do 1 minus, because that's what the not means. And now I can use my formula. So A or B, type in your chat the answer that you've got, please, for the probability of A or B. I've already seen some of them come through. Okay, and that's going to give you 0,85. Okay. Okay, Lamise, you had something else and then the 0,85. Okay, no, that's great. We're on the same page. Okay. Natalie, I seem to remember you could unmute. Natalie? I know you were having internet problems earlier, so I don't even know if you're actually still here. No, Natalie, I just saw you up here. Don't hide away from me.
Hi, ma'am.
Hey, Natalie. Oh, sorry, I'm saying Natalie and it's Natalia.
Yeah,
And
I got confused if you were calling me or somebody else.
I'm sorry, and I think I've been calling you Natalie all session. I apologize.
It's okay, ma'am.
Okay, so Natalia, it says
Yes,
here, an
ma'am.
entire sample space is made up of 2 complementary events. So before I carry on reading, can you remember what's special about complementary events?
It's complementary when it's not common in both and when it's on the outside.
Sorry, when you said not common in both, so that means no intersection, and then you said something else, I didn't hear you.
And then ma'am, I said, is it outside of the Venn diagram, like inside the box?
Yeah, everything's inside the circles.
Yes, ma'am.
Okay, yes. So absolutely, it's mutually exclusive, which is the whole thing of where there's no overlap, there's no common bits, and it is exhaustive. It means everything is inside the circles. Okay, so that actually leads us to 2 bits of information. For it to be mutually exclusive, I know that the probability of A or B is going to be equal to the probability of A plus the probability of B. That's the mutually exclusive part. The exhaustive part tells me that that is going to be equal to 1. So that's what I know with the complementary events. Okay, great. It says that P of not S, do you see they've used here the apostrophe? So that is not S is equal to 0,33. And it said complete the statement. The probability of S plus the probability of T is equal to. What do you think you're going to have to fill in there, Natalia?
Ma'am, am I going to have to fill in a 0?
Okay, so remember that was with the and part. So you're definitely thinking on the right line of things. Let's have a look at this information that I said the complementary meant. It means that my two events, obviously here I've got A's and B's, but they're talking about S and T. So the probability of S or T is equal to a probability of S plus the probability of T, which is what they've got here, right?
Yes, ma'am.
But then they also said the probability of S or T was going to be equal to
1.
1. Are we all okay with that? I saw a couple of people bringing it through and literally just a couple. So guys, these two bits of information, they actually combine to give us the statement that they've given us there. Okay. Now they said write down the value for the probability of T. And Natalia, before I start plunging into asking you to do the calculations, I want us to just think, if you look at the information they've given us the probability of not S. They didn't give us anything about T, did they?
No, ma'am.
Okay. But if we have a look at what they asked in the previous question, they kind of gave us a hint there that to get the probability of T, I'm going to need the probability of S. Do you agree?
Yes, ma'am.
Okay, so we did this trick earlier. If I've been given not S and I want S, how could I calculate the probability of S?
Ma'am, do you say 1 minus the probability of not S?
Absolutely. So it's going to end up being 1 minus 0,33.
Yes, ma'am. And then you get 0.67.
Yep. Okay, so now that I've got the probability of S, can you get the probability of T for me?
Yes, ma'am.
Okay. What must I write down? And remember, everybody, I want you guys to be sending your answers through in the chat as well.
Ma'am, I'm not sure if my answer is right, but I got 0.33.
Okay, so tell me what you were doing so that we can figure out if your answer is right. So probability of S, are you substituting into here, hey?
Yes, ma'am.
Okay, so the probability of S is 0,67 plus the probability of T equals 1. And then how did you get the probability of T on its own?
Ma'am, I said 1 minus 0.67.
And that's where you got the 0,33, and it's completely correct.
Oh, okay, ma'am.
Because the fact that they're complementary, Natalia, means that when I did the 1 minus or the not S is the probability of T, because probability of T is everything else. Does that make sense? That's what
Yes,
the
ma'am.
complementary means. Okay, brilliant. And I saw lots of answers coming, and people changing their minds in the chat. So I think they were having the same concerns as you, Natalia. Is this like, oh, wait, I don't know. This was my answer, but it's the same as it was at the beginning. And okay, but complementary means that the T is the same as not S. So in fact, if you realize that, you wouldn't have done any calculations at all.
Okay, thank you, ma'am.
Okay, thank you so much for joining me, Natalia. I appreciate it.
No problem, ma'am.
Okay, let's have a look at another Venn diagram, guys. The Venn diagram, I suppose it can be difficult to try and describe what you want to say or do, but again, always looking for volunteers. They like doing Venn diagrams and sometimes even in matric. So it's good practice. And the best way to practice is to actually be trying yourself. Okay. I think this will be our last question for the day. So I just want to make sure there's nothing else that I definitely want to cover. Somebody asked about tree diagrams. Do you want me to do another example with tree diagrams? I can't remember who asked. I did kind of show you where you could use tree diagrams in one of the questions for calculations. Do you want me to come up with a tree diagram example quickly? Otherwise, we are going to do question 5.3. Question B, 5.3 question B. Okay, great. Awesome. Okay, so it says a survey was conducted. Now I need you guys to be listening so you can answer questions in the chat, please. Among 180 residents of a small town to establish how many people contracted to TB, sorry, I cannot say that word, and a human immune deficiency virus, HIV, during the last 5 years. Okay, so TB, HIV, the results were as follows. X people were diagnosed with TB. Okay, so let's just quickly, the first thing they want us to do is a Venn diagram. So I'm going to draw my Venn diagram here quickly. And we can fill in the information as we go. So remember, you've got your entire sample space, and here we're talking about TB. So I'm going to call that T, and HIV, we're going to call that H. Okay. It says X people were diagnosed with TB. Guys, please, I want you to take note. The word only is so important in Venn diagrams. And when I say it's important, it's just as important when it's missing. Okay, so when they say X people were diagnosed with TB, that means everything in the TB is X. This entire circle is X. The problem is, do you see that that circle is split into two sections? It's got the one little sort of eye section and then the other sort of Pac-Man almost looking section. Okay. So I don't know which part of X goes on the one side, which part of X goes on the other side. So at the moment, I cannot do anything with that information. Okay, because the word only was not there. It is very important. If you see it, it's important. If it's missing, it's important. Make sure you understand the difference. Then it says 30 people were diagnosed with both TB and HIV. Okay, so TB and HIV, that is the middle section. That is my 30 people. So now I've used that piece of information. I'm ticking it off so I don't get myself confused, but I can go back to my highlighted thing. That whole highlighted circle had to be X. So what can I write in this other section for T? What can I write in the other section for T? It's going to be an expression. It will not be a number. What can I write in the other section for T? Type it in the chat. I'm waiting. What can I write in this other section? Okay, so all of you had the right idea. You wrote it the wrong way though. Oh, no, yes. No, you wrote it the right way. Apologies. Okay, it would be X minus 30. Remember, your entire circle was X, and I'm going to take out the 30 people that also were diagnosed with HIV. So it's X minus 30. Thank you very much. So is TB only X minus? Yes, absolutely. Great. Okay. So now I'm going to tick that piece of information off. I've done the first two pieces of information. Next one says 69 people were HIV positive. Okay, so that means the entire circle. This entire 69 people were HIV positive. So the entire HIV is 69. So I've already got 30 there. What am I going to fill in the other section? Okay, brilliant. Thank you, guys. You're going to go 69 minus the 30, and that gives you 39 in the other section, because that's the only part. And then lastly, 51 people did not have either disease. Where does the 51 go? Where will the 51 people go? Outside of the circles, but still in your block because they were still part of the sample space. Brilliant. So that is us representing the information on our Venn diagram. Okay, number one. How many people contracted TB only? So they now need us to calculate this X minus 30. Okay, so there's a couple of ways you could do it. Guys, I want you to remember in the story, they told us we asked 180 residents in total. So we are talking about the number of people. So 180 in total. I need you guys to tell me what equation we would land up using to try and get how many people contracted TB only. How many people contracted TB only? Okay, I've got an answer from Stephen. Okay, I've got jump straight to the answer for some of you. Okay. Okay, so I'm going to write down a formula and there's actually two options. Okay. First one is, remember, the entire section has to be 180. So 180 would be equal to the X minus 30 plus the 30 in the middle plus the 39 plus the 51. Okay, so you could have done that. You could have also said, well, this is what I'm trying to figure out. You're not really trying to figure out X. You want to know what the X minus 30 is. So you could have said that my X minus 30 is going to be equal to 180 degrees, and you just, not 180 degrees, sure, okay. Where did the degrees come from? Minus 30, it's because it's so hot. Minus 39 and minus 51. Okay, and you can just do that subtraction straight away. And that would give you an answer for X minus 30. So X minus 30 would be 60, 110, 120, would be 60. Am I right? Okay, guys, so please pay attention to the question. If they had asked you to solve for X, you would have got X equals 90. But they didn't ask for X. They asked for how many people got TB only. So do you see, you would have stopped there. 60 people had TB only. Okay, so pay attention to the question. It's okay if you solve for X. You would have got X equal to 90, but as long as you pay attention to the question, then you would have gone back and gone 90 minus 30, and you still would have got your 60. But your X value is 90, and then TB only is 60. Are we all happy with that? Okay, great. So that was question 2. That's how many people had TB only. Next question. Calculate the probability that a person selected at random will only have been diagnosed with TB. So now question A, the probability of TB only. That word only is so important. Type it in the chat and you don't have to simplify. Great. Okay, guys, so yes, we've got 60 people with TB. Over total people in my sample was 180. And yes, it does simplify to 1/3. Okay, next one. Will not have any of the 2 diseases. Will not have any of the 2 diseases. So if we have a look at the 2 diseases, the people who didn't have any, how many were there? Yes, I see the answers coming through for the probability. Probability of none of diseases. Great, it is 51/180. Okay, which yes, it might simplify. I'm not actually, type it in your calculator if you want to check if it simplifies. Guys, 51/180 is perfectly fine. In fact, that's usually what's in the memo. And then we always have to add the simplified version when we see somebody has simplified it. So really, it is not necessary to simplify, but as I said, double check with your teachers. Okay, guys, we've got 4 minutes left. I can go on to the next question, but just quickly before I go on to the next question, I want to find out, is there anything specific that something is concerns somebody that they want me to quickly answer or go through a question like that? Because it's our last question for the evening.
Ma'am,
Yes, Natalia.
ma'am, I just wanted to clarify. So after we get our answer, do we have to simplify it since it's a fraction?
So I would recommend asking your teacher, because I can believe that there might be some teachers. Remember, your teachers are the ones that mark your papers. At matric marking, you do not need to simplify it. They're focused on whether you can calculate the probability.
Okay.
So simplifying is completely optional, but double check with your teachers because they're the ones who are going to be marking your paper.
Okay, ma'am.
Is that okay? But yes, Natalia, so guys, simplifying is completely optional. But please just double check with your teachers. Thank you very much, Natalia, for asking that. Anything else that you guys want to ask? Okay, then we're going to quickly rush through this last very theoretical question, question 5.4. Actually, yeah, question 5.4. Okay, 5.4 question A. Says two events A and B are complementary, guys. So remember, if they're complementary, this is very similar to one we've already done. So I'm hoping there's going to be a lot more understanding and answers coming through, and make up the entire sample space, because that's what complementary means. It's exhaustive. And then they've given you the probability of not A. So remember, complementary tells you that the probability of A or B is equal to the probability of A plus the probability of B, because they are mutually exclusive. And the exhaustive tells me that that's going to add up to 1. So do you see that they all actually link to each other? All of those would be equal. So it says complete the statement. Probability of A plus the probability of B. Type in the chat. Yes, Brandy. Yes, Emma. Yes, Stephen. Yes, Natalia. Okay, we know that the probability of A plus the probability of B will be equal to 1. It says write down the value of probability of A and B. Okay, so remember, complementary means that it is exhaustive and that it is mutually exclusive. Okay. So probability of A and B. Yes, Brandy. Yes, Emma. Yes, Stephen. Okay, our last question for the night, guys. That is equal to 0. Because remember here, there used to be a minus the probability of A and B, but because they're mutually exclusive, we don't need to put it there because that is 0. Okay. Lastly, and let's see if you guys can do this in one step. Write down the value of the probability of B. The probability of B, remember, complementary means they are opposites of each other. So they've given you not A, but B would be the same as not A. So yes, Brandy, yes, Emma, yes, Stephen, yes, Natalia, brilliant. Straight away, that's going to be 0.35. Earlier, I showed you all the steps. Natalia and I did it together, where you can work it out the long way, and we all got confused because we landed up with what we started with. That's because if they're complementary, not A is the same as B, because B is the opposite of A. Okay.